Hello friends, welcome to GMD classes. So in this sessions we will discuss about inverse of trigonometric functions. Okay, so let's heading inverse of trigonometric function. Okay, so in the previous lectures we have discussed inverse of functions. What is the condition of inverse of functions? Okay, so I have told you inverse of function can be find out only for one and onto function. That is, function must be bijective. Condition is what? Function must be bijective. That is one and onto function. Okay. Whether a function of any types, the inverse of function should exist when the function should follow the condition of one and onto function, right? So for any functions, we can calculate invertible functions, inverse of the functions when the given function satisfy these conditions. Okay. So in this sessions we will discuss only trigonometric functions. So inverse of trigonometric functions, what is the criteria, what is the range, what is the domain, these all things we will discuss. So let's first start sine inverse x, cos inverse x, and tan inverse x, sec inverse x, cosec inverse x. These functions are the inverse functions, and so for study we will discuss graphical graph of these functions also. So first see the sine x. So I have told you, for to find the inverse of any functions, take the reflection, a mirror image of the given functions about the axis y is equal to x. If you take the reflections of any functions about the y is equal to x, then we get the inverse of the function. Suppose I want to find the inverse of the sin x. Sin x, see here, what is the graph of sin x? You can see this is the sin x. Okay, 0, pi, 2 pi. So entire one period you will see the graph of the sin x function. Okay, if you want to find the inverse of these functions, you can find, take the reflection about y is equal to x axis. If you this graph, and then you will take the reflection of this graph, these functions about the y is equal to x axis, you will get the inverse of function. So simply you can interchange y is equal to x or x equal to y. So for the simplicity, you can simply draw support about the y-axis. Suppose this is the y-axis, so it's better to draw these functions about the y-axis. Suppose, how can you draw? This sine function is in this way about this axis. Okay, and this sine function in this way. That is the same whether you take the reflection of the function about the y-axis, and it's better to draw about the y-axis and then take the value within the entire range. So first I would like to say, tell you, see here, invertible function is what? If you draw the sine functions, these functions, okay? So from minus pi, that is the 2 pi, this is the period of the sine function. So draw, see here, this function, if you take entire the range, entire minus pi to pi, this function is not 1. You see, if you draw the line parallel to the x-axis, you will get this function will cut at the 2 points. Suppose you draw the line, this function cut at that points and this point. So this function is not 1 1, this is the many one. So to find the inverse of the function, we will take the portions up to that the function is 1 1. See here, this up to these functions, I will take this is the pi by 2 and this is the minus pi by 2. Entire this range, you will see here, this function is 1 1, that is 1 1. If you draw any lines parallel to the x-axis or horizontal, you will see this function will cut at only one point. Okay, so that's why we are taking this function as this period, that is minus pi by 2 pi by 2. Okay, so we have to draw the inverse of the function up to this range, minus pi by 2 to pi by 2. So if you draw this, is suppose this case becomes minus pi by 2 and this becomes pi by 2. After that, we can replace y is equal to x. If you y put here pi by 2, x becomes pi by 2, minus pi by 2, then x becomes minus pi by 2. This vice versa interchange. So this range, in this case, this is the minus 1 and this is the 1. Okay. So this is the graph of the function. I want such I can only explain the sine function in detail. After that, all the functions we can only draw the simple curve. I will tell you the range and the domain within the function defined. Okay, so you can see here, if we draw the neat and clean here, you can see this becomes the range minus pi by, this is the minus pi by 2, this is pi by 2, this is minus 1 and this is 1. Okay, so up to this function, this curve, I have to draw only this portions here. I have to draw only this portions. Okay, so what you can see, one pair that is same here, up to these lines you can draw this. So this function is the inverse function of sine inverse x. Sine inverse x. What you say? In the similar way, you can draw cos inverse x, tan inverse x, sec inverse x, and cosec inverse x. I have only explained about sine inverse x in detail. Similar manner, you can draw these functions. Okay. So you can see here, x belongs to, what do you say, minus 1 7, including minus 1 7. Okay. Range is what? Range is nothing but, you can see here, minus pi by 2 is pi by 2. So minus pi by 2 to pi by 2. Okay, this is the range and this is the domain. So this value, then in this value the function is defined. Okay, and this is the range. Maximum value is pi by 2, minimum value is minus pi by 2. So simply you can draw cos inverse x. So cos inverse x, this is the cos inverse x. Okay, you draw these curves, you will see, if you similar way you can find in this way. So cos is what, nothing, this value and this value. So if you draw the functions here similar way, this is what 0, this is pi, this is minus 1, this is 1. So cos inverse x, what, x belongs to minus 1 7. Okay, range is what? Range is nothing but, you can see 0 to pi, 0 to pi. Okay, so this is cos inverse x functions, this is sine inverse x. Similar way you can draw tan inverse x, sec inverse x. So I will tell you only the domain and range of these functions. After that you can find in the similar way of the given functions. Okay, so it's better to draw here. So see, if you draw tan inverse x function, x belongs to what? All real value. In for tan inverse x, x belongs to all real values, and the range is what you can see the range minus pi by 2 pi by 2 here. Simple way, minus pi by 2 to pi by 2, but this is the range of functions. You can see here the graph. This value is minus pi by 2, this value. So you can exclude the portions minus pi by 2, pi by 2. Okay. So similar way you can draw, this is the functions of tan inverse x. Tan inverse x. Okay. So you can say x belongs to all real numbers minus infinity to plus infinity. This is minus pi by 2, this is pi by 2. See. Similar way, cot inverse x, you can draw cot inverse x, nothing but similar way. This is the cot inverse x. Sorry. This is the cot inverse x. You can draw these curves like this. Okay. So this 0 to pi and minus infinity to infinity. That is for the cot inverse x. X belongs to all real number. Range is what? 0 to pi. We are not taking 0 and pi because about this axis, this is up to tends to infinity, minus infinity to plus infinity. Okay. For sec inverse function, simply x is less than equal to minus 1 or x is greater than equal to 1. Same way for sec inverse function, x is less than equal to minus 1 or x is greater than equal to 1. So if you draw the curve, you can see in such a way for cosec inverse functions, minus pi by 2 pi by 2 here, this is the range. Okay, this is minus pi by 2, this is pi by 2. Okay, this curve is minus 1, this curve is 1. So when you say about 0, cosec inverse x less than minus 1, x greater than 1, whether this function is this side and this function this side. So you can see when you put the cos 0, that is 0. When you put cos pi by 2, 1, cosec pi by 2, 1, sorry, cos pi by 2 0 time. So in this way you can see these portions like that in this way. Okay, sorry, this is not like that. If you draw the curve here, you can see these points up to 0 and you will see here these points up to 0. So in this like this is the functions of cosec inverse x. In the similar way you can find sec inverse x. Sec inverse x, what you can see here, this is the sec inverse x functions, 0 to pi, entire in 0 to pi you can see, but not including the portions pi by 2. Pi by 2 you know. And this way this is minus 1, this is 1, because sec inverse x less than minus 1, minus 1 and x greater than 1, whether this function lie up this side and this side. So we can take pi by not defines here, so this way you can see here this is the functions and this is the functions. This is symmetric about this lines, y is equal to x. You can see here this line is nothing but white. Okay, about this line. So in this way you will see here the inverse of the functions, whether sine function, cos function, sec, cosec, tan, cot, all these functions I have discussed. Okay, so another theory I will give you. Let's see here. Okay, so one basic basic theory, a concept you can consider principal value. Principal value. So principal value is nothing but the least minimum rotation you can see about about whether you go in clockwise direction, anti-clockwise direction. In this range, you will get if the all the functions of the trigonometric functions, all the value of the trigonometric functions obtain, then the least rotation, that is called the principal value. You can see here the principal value is the least rotation in which the entire value of the trigonometric functions are obtained. Then this value is called, this rotation is called the principal value. Suppose if this here, this is 0, this is pi by 2, pi and 3 pi by 2. Okay. If you rotate in this way up to that, suppose 0 to pi, the angle is what? 180 degree. You rotate in anti-clockwise direction. You can rotate also in clockwise direction. This is the clockwise, this is anti-clockwise direction. Well, same 180 degree in clockwise direction or 180 degree. In this condition, if the clockwise rotation and anti-clockwise rotations are same, then we should follow anti-clockwise then rotations. Okay. So in this condition, when the clockwise and anti-clockwise are same, then we can consider anti-clockwise rotations. Suppose here, if I want this angle, so in this angle I go and in this angle I go. So in anti-clockwise rotations, this is the maximum angle you have to rotate, and if you go in clockwise direction, you will get least angle rotation. So in these conditions, we will follow clockwise rotation. Okay. So we have to think about which rotation is least. The main value is the least rotation. Principal is what? Least rotations. Only least rotations we should consider. So whether in the clockwise or anti-clockwise, don't bother about that. Okay. So sine inverse x, you can consider the principal value is nothing but minus pi by 2 to pi by 2. Okay. Cos inverse x will what? 0 to pi. Same tan inverse x belongs to what? X belongs to all real numbers. Cot inverse x, so least rotation is same. Tan inverse you can find minus pi by 2 to pi by 2 minus 0. Okay. Cot inverse is nothing but 0 to pi minus pi by 2. Sec inverse x same, 0 to pi. You can see here, sec inverse 0 to pi, cosec inverse x 0 to pi. Sorry, minus pi by 2 to pi by 2, no doubt. Okay, this is the conditions, this is the least rotations. Okay. I will tell you how to solve numerical problems. If for that you should learn about some more concept here. Suppose some proof to sine inverse x, that is sine inverse sine x. You can see cos inverse cos x, the way the sine of sine inverse x, cos of cos inverse x, tan of tan inverse x, or you can say tan inverse of tan x. So these functions, how can we calculate? This is nothing but only x. These all are x. But what is the conditions for obtaining this value? If suppose you are given sine inverse of cos x, then how can you find such types of questions? Yeah, tan inverse of cos x, how can you find? So for such types of questions we need some concept. So I will give you the basic concept up to you can solve any questions. Okay, so first some more basic concepts are left. I will tell you. Sine inverse minus x, you will nothing get minus of sine inverse x. Okay, same of cosec inverse of minus x minus of cosec inverse of x. Okay, cos inverse of minus x, you will get pi minus of cos inverse x. Cot inverse of minus x, nothing but pi minus of cot inverse of x. Similarly, tan inverse of minus x, nothing but minus of tan x. Sec inverse of minus x, nothing but pi minus of sec inverse x. So these are the basic concepts. You can say one. I will give you the proof. Suppose sine inverse minus x is equal to theta. Okay, so sine theta is nothing but minus x. You can consider x is equal to minus of sine theta. So we know x equal to minus sine theta, nothing but sine of minus theta. Sine of minus theta is nothing but minus of sine theta. We can see. So this is the value x. I have assumed this is the x equal to sine theta. Sine of minus theta is nothing but x. So you can see here minus of what? Sine inverse x is equal to minus of theta. Then theta is equal to minus of sine inverse. This is the proof. We can see it. In the similar way, you can put and then find the value. I will give you the cos inverse x. What happened? Cos inverse minus x, nothing but theta. Assume then cos theta is nothing but minus of x. Then x is nothing but minus of cos theta. You can replace minus cos theta, nothing but cos of pi minus theta. What is it? Cos of pi minus theta. Then what is a pi minus theta is nothing but this is x. So cos inverse of x. So you can see here theta is nothing but pi minus cos inverse of x. You can prove. So in the similar manner you can prove all these functions are same. Okay, so I will give you some other more concepts. Let's see here some basics. Sine inverse x plus cos inverse x, nothing but pi by 2. Similarly, sec inverse x plus cos of pi by 2, cot inverse plus tan inverse x pi by 2. So these are the basic definitions. Okay, so I will give this proof. You can similar way assuming sine inverse x with theta, then you can put cos inverse x, and then after putting the value you can get same here. I will not going to prove these functions. Now I want to solve some questions. How to solve some questions? Suppose question 1 for getting sine minus root 3 by 2. Okay. This question is given sine inverse minus root 3 by 2. Not how can you solve? First you learn sine root 3 by 2. Minus root 3 by 2 is nothing but sine is negative in which whether this and whether this. So root 3 by 2 is nothing but sine 60 degree. What is sine 60 is nothing but root 3 by 2, that is pi by 3. But minus pi by 2, you can see minus sine of pi by, you can see assume pi by 3, nothing but minus pi by 3. Okay, so this minus pi by 3 belongs the regions minus pi by 2 to pi by 2. Okay, if this value is not belong to this range, then we have to sum some mathematical operation so that we can lie the given value in this range. Okay, suppose sine inverse minus root 3 by 2, yeah, 5 pi by 6. I will take this. What is the value of this function? This function doesn't lie in this value. So first I have to do some mathematical operations so that we can lie. This is nothing 130 degree, 150 degree. What is 150 degree? So for that we to lie in these regions we have to subtract whether in this pi, yeah, minus pi by 2. So we can write here what sine inverse, this value is nothing, you can see here in this range, but this value is this range 150 degree something little, this is the 90 degree. Okay, so we have to subtract in this value, subtract some value. So how can we write? So pi minus pi by 6, if we write we get 5 pi by 6. Okay, so we can subtract from the pi value so that we can get the entire value from minus 90 degree to 90 degree. Okay, so this is pi minus theta, something nothing but theta, because this is the pi. So if you subtract any value from the pi, this will lie in the second quadrant. In the second quadrant sine is positive, so sine inverse pi by 6 simply we can write here. Okay, so this value is nothing but if you take this types of function can be given in complex mode. Suppose I will give you sine of sine inverse x. Okay, sine of sine inverse x,